Okay, I think we have about one more minute and then we'll begin. Okay, my name is Bob Kizek. Welcome to this edition of the Friday WebEx. Our topic this week is going to be a new product called the ITM 51. It's a turbidity sensor. As we always begin with these WebExes, we want to discuss our mission statement for Anderson-Negele, and that's providing complete sensor solutions and services for hygienic process engineers in dairy, food, and pharmaceutical. Certainly with the introduction of a new product, that certainly sits very squarely into this mission statement. So I'm going to start looking backwards. So hopefully you all know what an ITM-3 is. That's currently our backscatter turbidity monitor. We use it for applications in dairy plants for phase transition, for CIP pre-rinse control. We also use it in brewing for yeast harvest and lauter ton control. As a device, it was rather revolutionary in that it was very simple to use. It was not complex, quite honestly, didn't require you to open up the manual to understand how to use it. It was an all-integral design, and it was very compact. As a backscatter device, we had a single tri-clamp mounting onto a process pipe, and we had the sending of light into the stream to realize the particles that are present. Because turbidity, as I'm sure we all know, is the measurement of the effect that particles have on light. And the higher the concentration, the more will affect that light, and the ITM-3 would interpret the presence or the concentration of suspended particles. Now I'm going to change gears. So we talked just a little bit to kind of get you on track thinking turbidity, thinking about the ITM-3 that we currently offer. And now I'm going to shift over to a design philosophy that Anderson-Negele has been implementing on their products. And that is a modular sensor design that became a platform that's yielding a series of products. So you're familiar with the NSL-F, which is our potentiometric level device, or the ILM-4. You've already been introduced to the modular sensor platform. This is a series of very scalable sensors. So now we can add or subtract features and appearance or function from the device because we have this modularity. There's some benefits that come from that, right? Flexible configuration, as I use the term also scalable. You're only going to purchase or build a part number that satisfies your application need. You don't have to purchase a product that's burdened with additional features that you're not going to use. In addition, there's a standardization of components. So that has the potential that, if you're stocking spare parts for devices, you only have to have a handful to be able to service all the sensors in your plant. And in addition, there's a universal operating concept, meaning that they're all going to behave the same. If you pull it out of the box, the menu structure is the same, the connections are the same. So once you learn one, you've learned them all. And then lastly is that we have a remote version now available for anything that's on the platform. So as I mentioned earlier, and just to put it into image form, modular sensor platform currently available on the NSL-F If you've purchased one, you've noticed that the LN had migrated to the NSLF and it's changed physically. The ILM4, which superseded the ILM2 and ILM3, and now we're going to have a turbidity product, the ITM51, which, much like the ILM4 is replacing the ILM2 and 3, the ITM51 is going to ultimately replace the ITM3. And so, introducing the ITM51. Doing a comparison. So I'm sure the first thing is, well, we've got this list of customers and they all love the ITM51, use it in their plant. How does this compare to it? So for starters, on compatibility, the electrical connections can match the ITM3. Use the term can for a very specific reason. There is more than one wiring option for an ITM51. And a little later in the show, we'll go and look at the matrix and I'll explain to you the differences. But suffice it to say that if you pick one version, you will have direct compatibility to the ITM3, and we'll make sure to highlight that specific configuration. In addition, the measurement of the sensor is compatible with the readings of the ITM3. That means if you're, again, familiar with the ITM3 measured in percent of TU. So it would measure from 0 to 200 in percent of its capability. The ITM3 will match that reading. So it will, out of the box, if you configure it for a range of 0 to 100, should directly match an ITM3 configured for 0 to 100. There is a reduction in size. So even though the ITM3 was compact and small in comparison to other optical devices, the ITM51 is 30% smaller than that. So it makes it even easier to fit it in between pipes and on pipelines in tight places or on skids. So life just got a little simpler. And another benefit from having less size is less mass. Less mass means that if we have vibrating lines, severe harsh applications, we have less mass to put into motion, and so we're going to survive better in those applications. From a temperature range or temperature application standpoint, the new device can withstand up to 266 degrees F continuous, whereas the ITM3 had a 212 degree limit. For CIP and SIP, we can now go to 302 degrees F for 2 hours, 120 minutes, whereas the ITM3 had a limit of 266 for 30 minutes. And this is kind of critical because if you're going to go into a sterilization process, oftentimes that sterilization process can be interrupted. And what winds up happening is that sensor is held for a longer period of time than the required 20 to 30 minutes. Well, with the ITM3, what you are basically doing is subjecting that device to a longer duration than it was designed for. With the ITM51, we can now withstand that legitimately with no negative effect. Moving on with the comparison units of measurement. I mentioned earlier about the ITM3 and the fact that it would measure in percent TU. TU being a Negele turbidity unit means it didn't align with any measurement parameter outside of Anderson-Negele. The ITM51 is selectable. So it'll come out of the box set percent TU because that'll be, it'll be configured to be used as a replacement for an ITM3 at this point, or for a typical customer application from a customer who's used the 3. But it also can be configured to read out an NTU or EBC equivalent or percent solids. So if you have mapping between NTU and percent solids for your product, and it's desirable for you to have percent solids output by this device, you can enter in the points on the curve to identify a solids curve in relation to NTU measurement. That's customizable within the software. From a measurement range, so just overall, what can this device do? The ITM3 would work from about 2,000 NTUs up to 300,000 NTU. equivalent, whereas the ITM-51 now goes down to 200 NTUs up to 300,000 NTUs. So the maximum capability of the product has stayed the same, but the bottom end has gone 10 times more sensitive than the ITM-3. What does this mean? Well, this is the curve that we've shown for several years now with the ITM-3, showing what the unit will read based on the product that you subject it to. And what's key to this is that anything below that red line kind of came into the question mark within ITM-3. So if you look at things like orange juice or tomato juice, you really started to get into a question mark on whether you could measure a dilution down to 30% or so. Well, with the ITM-51, we've now filled in that measurement down to 0.14% TU. So right down to the very bottom of this graph, we can now give a reading and an understanding of what it is the product is in the line. Some other things with the ITM-51 is the pressure capability. So the ITM-3 was rated at 232 PSI maximum. The ITM-51 now has a vacuum rating, so it's from minus 14.5 up to 290 PSI. Anyone's familiar with the earlier versions of the ITM-3, there used to be an elastomer used to seal the lens against the stainless steel fitting. That elastomer no longer exists, and that lens is bonded directly to the stainless. So that's given us the vacuum capability, and in addition, a stronger seal, so we have a higher pressure capability. Another neat feature on the ITM-51, and this comes up periodically as someone has an ITM-3 and says, what happens if I test it and it's changed in reading and I want to be able to adjust it? And the answer is that in the field, there is no adjustment for an ITM-3. An ITM-51 has a zero and span value within it assigned to both turbidity ranges, and so you can adjust the reading of this device based on a calibration check. In addition, for future use, there will be a reference plate that can be purchased to check the devices against. So you'll have a dry check that you can just simply set the device onto a reference plate, look at the reading, and if it was required, you can adjust it to match the reading that it should be giving. So, all these nice, neat features, what do they give us? Well, the ITM-3 has been great at improving sustainability in dairy plants. It's given us, recovery of products through phase transition applications and optimization of CIP, all things that reduce putting product down the drain and using excessive water in a plant. Well, the ITM-3 with the temperature increase in capabilities means that you can now take that turbidity measurement that we were using all at lower temps in a plant and move it into the higher temperature processes such as ESL. So now ITM-51s have the ability to migrate into those applications. In addition, that CIP rating gives us the ability to sterilize effectively. In addition to the temperature capability, which allows us to reach out into other processes, that range expansion has a direct play also. So in the past, with the 2,000 NTU reading on a ITM-3, you could still have water that you could see with your eye. It wasn't clear. And so you could not use this on a higher clarity application. And the one that comes to mind for us was beer separation. So after fermentation, you'll run the ferment through a centrifuge to go and pull out the solids that remain in it. Well, in the past, you couldn't use an ITM-3 to go and do that because it didn't have enough resolution on the bottom to give you a clear product. The ITM-51 now offers us that resolution. And so we have a new application, and that's beer separator control. So this is replacing the use of a timer on a separator with a turbidity control to control how often that separator is going to desludge. What's kind of key to this application, in addition to the expanded range, is the ability to measure in other units, such as NTU or EBC, because now we need to correlate to a value the customer's already got in their mind, and it's probably an EBC value that they're interested in a beer application. Another point is the output configuration of an ITM 51, and this drives back to that platform conversation we had a little earlier. That output for turbidity is now freely programmable. So in the case of a ITM3, we had some fixed ranges that you could select for the 20 milliamp output. In the ITM 51, similar to the ILM4, you can freely assign a 20 milliamp point to any turbidity measurement within the range capability. I put in a couple slides kind of going back to the basics on turbidity installation, because I think periodically we have to bring this up into conversation, and it's about the mounting of a turbidity sensor and why it's important to put it in the pipeline in the correct way. So we always want, the key here is that we always want to orient that device so that it's submerged in liquid and not being exposed to possible air entrainment. So we want to use a short outlet T. A short outlet T is a T that only has about a 5/8 of an inch rise off of the pipeline. And we want that because we want that flushing to be immediate. We want that area in front of that lens to change over to whatever's going on in the pipeline virtually immediately. And in addition, if we're going to be selecting products that are heavy viscosity, the same as with the ITM3, we need the long lens extension, and we'll show that a little later again when we look at the matrix. So orient it to keep the liquid on the lens, use a short outlet T. Straight pipes are a good location for the stability of a reading. Positive pressure improves readings, and the reason is if there's any entrained air or gas in the liquid, positive pressure compresses it, and so it minimizes its impact on the reading. And I always point the electrical connections down. That's to keep the water from settling into those connections. And then lastly, in very hard to flush applications, I want you to take note of this bottom application where we recommend that you put it into the elbow with the lens, in essence, facing into the product flow. And so now you can see if you have a very thick product, but we have water flow coming through, it will assuredly flush off that lens virtually immediately when it comes through the pipeline. So I mentioned earlier about the wiring selections and that you can directly, or I should say, get an ITM 51 that's plug and play with an ITM 3. That is electrical connection A, shown here on the right-hand side. An electrical connection A, as it did with the ITM 3, puts the primary analog output and the power supply into a single cable. So you need a single power cable and signal cable with an M12 connector on it to connect to the device. If you selected type N, what you're going to wind up with is you're going to need to use two cables to power the device and utilize the inputs and outputs. This, however, would be a configuration that you would typically see on a sensor if it had come from on a skid from Europe, because in Europe they had used this configuration instead of the A configuration for many years. And the last configuration is M, which is an output for the A42 module choice. So in this case, you have a device that's only going to have an analog output, and so there's absolutely no sense in having two M12s, so a single M12 is used. And keep in mind, though, it does have a slightly different pinout for the A42 with the M option. Remote versions. So we didn't have an ITM3 in the US that was available easily with a remote application. So everything we sold was integral electronics. However, there are certain applications where you have high vibrations or difficult to access points, or you want to have the display somewhere where you can actually see it or all located in the same location, that remote solves that issue, right? We could have the sensors scattered throughout a room, and we can have it all cabled back to the head mounted in convenient location. Some of the nice features of our remote version of an ITM, as it also applies to an ILM, is all the communication between the sensor and the electronics is digital. So we don't have to worry about environmental noise corrupting microvolt signals and damaging the reading of the device. We're immune to that. We've got protection and we've got a digital signal. So we're sending the actual turbidity values to the electronic where they'll display an output in the form of a 4 to 20 output. It is an industry standard M12 connector with 8-pin cable, but it is a complete assembly that's not disassemblable and shortenable. So I recommend that if you know your distance, order the cable for the distance that you're going to apply to. Now the other point on this is, and this spoke earlier to the ability to stock parts in varying quantities, the sensor is where all the processing electronics are and where the calibration is held. So if you damage the sensor, you wouldn't have to go and configure the electronics after you swapped out the sensor. You'd simply unscrew that M12 connector, replace the sensor screw on, and it's immediately going to be ready for use. So it's another nice feature of having the processing electronics separate from the outputting electronics. So here's the matrix. This is what we will have. This is posted up on the web now. If I was replacing a typical ITM3, so we're talking about what probably comes up at about 85 to 90% of all the ITM3s we sell. You're going to get a 2-inch tri-clamp connection. You're going to get vertical for orientation, and so that vertical means that I think every image I showed you was vertical, where the electronics can, let me get to one real quick here, where the electronics can sit in line with the sensor. This is a vertical orientation. Well, horizontal, this is turned sideways, and so you can see that can be an advantage if we're in a horizontal line and we wanted to have the head come off, but of course, as our mounting indicates, we wouldn't want to be on the top of a pipeline, so we typically would want that split off to the side, and so we would still take a vertical application even for a horizontal. Back to the configuration matrix. So here are our output changes. So now we can select what it is we actually need for the application. If the customer is replacing an ITM3, the safe bet is to get an A53 module because that carries all the input and output capability that the ITM3 had. So if you don't know what they're doing with it, but you need to get it on order, you need to order an A53 to cover all the bases. However, if the customer knows all I need is a 4 to 20 milliamp output with turbidity, you can readily select an A42. Just keep in mind that he will have to wire his cable differently if he's retrofitting. And that goes back to the wiring diagram I showed you earlier, that an A42 does have a different wiring configuration than an A output. So again, if he wants plug and play, he's going to have to stick to an A52 or A53. Minimally, if he just wants an analog output, but he wants it to be plug and play, you'll need to go with an A52, A53 if you want the full capability. Electrical connection. As I mentioned earlier, you want configuration A to be able to directly refit to an ITM3, and it's also, if they're using just for 4 to 20, it's the most convenient because you only need one cable to operate the device. Interface/display, I've checkmarked the L because it's a nice large display, easy to read, and that kind of aligns, or I should say that somewhat aligns with what the ITM3 had. The ITM3 had a fairly visual display, and L will give you a very visual display. Enclosure, I checkmarked P, plastic cap with sight glass. It's a good solid cap, gives good visibility. and it's significantly less in cost than the stainless cap with sight glass. Understand that the stainless cap with sight glass is a stainless steel ring with a polycarbonate window attached to it, whereas the clear plastic cap is a solid plastic cap. So if the customer really wants stainless, they can certainly get the W, but I would think in most instances a P would be applicable and work for them. And then lastly, parameter configuration is an X. That will bring it with standard configuration, much like all the ITMs shipped. So an ITM 3 was configured for 0 to 100, and ITM 51 is going to be configured the same. You can see on the right side, using that guidance for configuration, an ITM 51, because of the plastic cap, will be a little less than an ITM 3 of comparable size and feature. So, to go into the summary of what we just went through, it's on the website today. So if you have a customer that has need for an ITM 51, and in particular for the advantages of an ITM 51, we will take an order today for that product. Expect delivery to probably be in about 4 weeks for it. The ITM 3 is still available, and I would not recommend any customers who are asking to purchase an ITM 3 today, I would not stop that order from going through. I would put that through because we have stock, we have the ability to satisfy it immediately, and they're going to get exactly what they're asking for. So I wouldn't change any orders. I wouldn't stop it, stop the process, keep that going. Certainly you can introduce the ITM 51, and if the customer wants to take that path, we'll do it. Within a couple months, though, expect that we are going to pull back on the ITM 3, and we probably won't be stocking any longer. So, then we'll have a shelf full of ITM 51s ready to satisfy orders. Keep your eyes and ears open for those additional application capabilities, right? Listen for those words. Yeah, geez, we love the ITM 3, but we couldn't use it in these 12 other applications because the temperature was too high. And you get to now go, whoa, 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 how high? I think I've got something. And then the last part of this, use scalability to meet application needs. So, look at that price matrix. Help your customer. If the customer only needs an analog output, only sell them an analog output. So don't forget, you should receive an email in about 30 minutes, and it'll contain a PDR for a special discount on the ITM products, and that'll be all products, ITM 3 and 4 and 51. And now I'd like to open it up to questions. And the first question is, what does EBC mean? And that is the European Brewing Convention. So it's units that were used by European breweries to measure turbidity. And so it has much more strength in Europe, but it still resonates with a lot of U.S. brewers. Any more questions? Got someone typing? Good question. Talk about phase separation using conductivity versus turbidity. Phase separation using conductivity means that you can only make a decision based on the electrical change in that liquid. And what is key, and in particular what is key to a dairy plant, is that we are interested in undissolved solids because that's where the money is in a plant. And undissolved solids don't necessarily affect conductivity in the way we would expect it to or wish it to, meaning that if we've got fat in our product, that doesn't add to the conductivity of that product, and so we would miss the fat with a conductivity sensor. However, a turbidity sensor measures undissolved particles, and so now we get the picture of where is the money going in the plant. So if we've got product going down the drain, the turbidity of that discharge is going to be high, and we know we're losing the gold. So that's the difference, is turbidity more directly follows where the product is in the plant and when it's being lost, whereas conductivity, you're making an assertion that, well, if the conductivity is high, it must have the valuable stuff in it, and if the conductivity is low, it doesn't. That's not necessarily true. Question, will we have a cut sheet targeting the brewery industry? We have some applications currently online that we will upgrade with the new product headings, but the applications themselves are still, directly there. They're meaning that the yeast harvest and the launder ton control, those are there already and certainly available under. If you go into industry on our website and then go look under brewing, you'll see those. I'm trying to understand what this one's saying. Up a little bit more. Someone has a question. We use the ITM 3 with dairy products, but we see a difference in reading. And I don't okay. Well, yes, homogenized versus non-homogenized. Non-homogenized, turbidity is affected. Going back to the original statement, turbidity is the measurement of the effect that particles have on light as it passes through. And when we homogenize, of course, we're taking the fat globules and we're breaking them down to a much smaller size. That means that the amount of surface that's available within those pieces, even though there's more particles, the surface and the amount of surface that shares the same angle for reflection changes. And so, yes, you can expect that if you have more but smaller particles, that will read a different turbidity than large but fewer particles. Any more questions? Question thrown up, can it do Greek yogurt phase detection? The answer is yes. The key in that one, you use the term yogurt and Greek meaning viscous, so we would want to make sure that we use the extended length versions. I didn't highlight that in the conversation, but if I go back here, when we were talking about connection selection up at the top, and I said 2-inch tri-clamp, if you were looking for the long, which is that protruded lens where it goes deeper into the length, we would be selecting a TL2 tri-clamp with long. So yogurt, make sure you get a long lens, but yes, will work. Any more? Can the ITM 51 be repaired? Yes, there are Certainly, first off, the screw-off components, the cap, the connectors can be changed, the display module can be changed, and the processing puck in the head can be changed. From that point, the housing and the actual sensing head, that would be replaced as a complete assembly. Okay, I want to thank you all for attending. I think I'm on in another 2 weeks, so if you don't like hearing my voice, show up anyways. But have a great weekend. We will talk to you later.